Our next speaker, we've got a tag team here, to talk a little bit about what is Trove, how it's used, how it works. Between Nikhil Manchanda, who's the PTL for the Trove project from HP, and Doug Shelley, who's runs development for us here at Tesora. So with that, I'll pass along to these guys.
Thank you, Ken. So just before I start, we've all sort of gathered here to talk about Trove and discuss Trove. I want to mention that this Trove Day comes at the cusp of the Trove mid-cycle meetup, which is happening over the next 3 days. So it's really good to see a lot of you Trove contributors and folks here, a lot of familiar faces. And a big thank you to Tesora for helping put together this mid-cycle meetup in Cambridge. And looking forward to all the discussions that we're going to have there. So that said, let me get started with a short explanation about what exactly is Trove, and give you a few details about sort of what we've achieved so far and what's coming in Juno and beyond. After I sort of speak to a bit to that, I'll sort of hand over to Doug, who will give you a bit more sort of hands-on demo and talk about some of the exciting stuff that we've done in Juno, including replication. So let's get started. Just wanted to sort of mention the Trove mission statement. So Trove is an integrated project in OpenStack, and its mission statement simply reads, to provide scalable and reliable cloud database as a service, provisioning functionality for both relational and non-relational database engines, and to continue to improve its fully featured and extensible open source framework. There are a few salient points that I want to call out that are part of this mission statement. The main being that Trove really is a database as a service provisioning functionality. So it's the glue that helps you get running with a database service, and sort of helps to manage and secure that database service. It really doesn't deal with the data plane layer at all. So you actually use the service itself when you need to manage data as part of your database service. So also, our charter now extends to both relational and non-relational databases. And we're completely open source. So being part of OpenStack, integrated with the OpenStack release, we're completely open source. So what exactly is Trove? As I mentioned, it's a service to provision and manage databases in the OpenStack cloud. And as part of this service, Trove inherently exposes APIs that you can use to sort of provision, not only provision your instance, but scale instances based on your footprints that you need for your application, kind of like how much memory you require, how much CPU you require. Scale based on storage size. So if you need a database that requires a larger volume size, for example, you're able to scale that on the fly. It also has APIs that let you take backups and make restores of those backups in a managed way. And apart from that, it has a few extensions that let you sort of manage your database schemas and users' permissions. And sort of security groups and things like that as well. Wanted to sort of go over a bit about the Trove architecture and the different components that we have in Trove. Some of you might find that helpful. So the Trove architecture sort of starts off with the API request being handled by what is known as the Trove API service, which is basically a WSGI service that then communicates to the Trove task manager, which is where sort of the gut of all of the provisioning and all of that takes place. And the way it communicates, the API service communicates with the task manager, is basically through a shared database and a message bus. Now, this database and message bus sort of is shared with the rest of the OpenStack components. So if you use DevStack to do a Trove install, you could use either MySQL or Postgres for your database, and usually RabbitMQ for your message bus. So once the request comes in, Trove the API makes a call through the message bus to the task manager, says I need to provision a database instance. Task manager then sort of goes out and talks to the other OpenStack components like Nova, Cinder, and Glance to actually do the provisioning. So as part of the provisioning for the particular database component, so say if you're trying to deploy a MySQL image, there's a MySQL guest image that's stored in Glance. The task manager says boot this guest image as a compute instance in Nova using a volume size that you specify as part of the API request. Once that's done, sort of the Trove guest image is up and running, and Trove now has a guest agent service as part of that guest image that comes up, does its own health checks, makes sure that the actual database service is up, running, things check out, and it sort of sends a health message back to the Trove system saying, hey, I'm up, I'm running, your database instance is active. And sort of that communication between the guest image and the rest of the Trove system happens through this Trove conductor component that basically is responsible for relaying messages between the Trove guest and the Trove task manager. So there are also these sort of side boxes with Keystone and Nova networking or Neutron that exist because sort of Trove uses Keystone to do identity management. And Trove works with both Nova networking, the older model of networking in OpenStack, as well as now we've recently added support for Neutron. So if you're using Neutron in your OpenStack ecosystem, we can work with that as well. So managing a Trove database, what does it actually involve? Sort of what can you do with Trove to make database management a little bit easier? So with the Trove API, with MySQL extensions, you can use the MySQL extensions to create your database schema layers, create users, and then use the APIs to grant permissions to particular schemas that you created through a user. Now, if you don't want to go through the whole sort of API programmatically creating these schemas and users through the API, what you can also do is enable a root user who now has access to do all of these things, and you can connect using the root user and create your own schemas and other users as well. I touched upon this briefly earlier. We also have APIs that let you resize flavors, which uses, underneath the covers, uses Nova resize to actually change the number of processors or the memory that your flavor is using. And we also have a separate API that lets you resize the volume. So say your database was on a volume of 2 gigabytes. Now you want to use a Cinder volume that's bigger because your data size is larger. You could do that on the fly. Want to talk a bit about where we are with Trove backups. We have an API that lets you take a backup of your database data. The API is fully managed, so you don't actually have to connect to the database to do anything. It can be triggered and tracked via the API, so you make an API request to kick off the backup, gauge how the backup is progressing through the API and gives you back status. And then once it's complete, it tells you it's complete and where in Swift the backup is stored. The backups are streamed to Swift, so you don't need extra space on the actual MySQL volume, on the actual database volume. In the last cycle, we also added support for incremental backups as well as full backups. So what you can do here is you could say a given backup is a parent backup, and you want to create another backup as sort of an incremental backup over the parent backup, so you don't have to store all of the data that's already present in the parent backup. When you do a restore, it then just replays the sequence of backups so that you arrive at a consistent location with your incremental backup. So Trove for MySQL supports 2 formats. It supports extra backup, which is a Percona tool that a lot of folks in the industry use to take MySQL backups. And we also support logical backups using MySQL dump. So Trove in OpenStack is sort of also gives you this benefit of being able to tune your database installation. So things that Trove handles is it allows you to automatically tune your MyConf, MySQL configuration settings by flavor. So for example, if you're using a flavor size that has more memory, you can tune your buffer pool size, your max connections accordingly. And if you're restricted by memory, if you have really tiny instances, you can make sure that you have smaller caps on those. Trove has sane defaults, and you can configure the defaults to sort of what's needed in your environment. A lot of folks that I know who use Trove turn on InnoDB only and disable load data in file and select into out file for security reasons. So Trove allows you to do things like that. Also, in Icehouse, we added a new API, which allows you to programmatically set configuration groups. So now you can sort of set these myconf parameters, but you could also allow the user to change a certain subset of these myconf configuration parameters depending on what you configure. So say you want the users to be able to programmatically specify values that they want for max connections. They can now do this through the API. Trove is secure. So there's a bunch of options in Trove that let you tune Trove accordingly to do things to make your database installation more secure. There's a Trove extension that lets you manage security groups to your Trove instances. So by default, Trove ships with this extension where port 3306 is the only port that's accessible to your Trove instance, so folks are not able to SSH and sort of manage the instances themselves. Of course, if your environment requires that, you can change the defaults and open whatever ports are necessary. Trove also removes sort of non-local host users, anonymous users, local file access, and by default mangles the root password, and also has ways in which you can apply security patches automatically so that the actual database service is managed and the users don't have to care for that. OK, so that sort of gives you a brief overview of what Trove is, what the APIs handle, and what sort of some of the benefits of using Trove are. I also wanted to sort of quickly go through features that we have in Icehouse, we have implemented, and give you a brief peek at what are some of the features that are yet to come that we're still working on in Juno, and that will sort of form a lot of the basis for our discussion during the mid-cycle meetup tomorrow, or over the next few days. So in Icehouse, we added support for non-relational database types. So now Trove has a concept of a data stored type and version. We added some initial support for non-relational DBs like Cassandra, Mongo, Redis, and Couchbase. Currently, this non-relational sort of DB support only supports single instances, and we don't support clusters in Trove currently, but that's something that's work in progress, and the folks at eBay have been making good headway into that. And there's a whole sort of session around that discussion that we're going to have as part of the mid-cycle meetup as well. So we also added DNS support in Trove. So as you know, there's this project in incubation called Designate. And so Trove integrates with Designate to actually provide DNS hostnames. So before this, once you provisioned a Trove instance, you'd get back a sort of IP address, and then your application could then use that IP address to connect to the database. And so now, if you integrate with Designate, instead of handing you back an IP address, in addition, we also hand you back a DNS name. And sort of we call the Designate APIs, and Designate under the covers works with creating the DNS records and things like that. So Trove doesn't do any of that. It just integrates with Designate to do that. I briefly spoke about this earlier. In Icehouse, we added support for configuration groups. The ideas behind configuration groups is pretty simple. It allows you to specify user-defined configuration settings. And the list of settings that users can define is configurable as well. So there's a template section that says, OK, users are able to override these certain myconf settings. There's sanity checks there. These are the min values allowed for this setting. This is the max value allowed. This setting is of this type, that kind of thing. And then Trove allows you to sort of group these settings and target these groups to certain instances. So say you have a production DB that you need to be able to set X, Y, and Z settings, but you need to be able to, in addition to setting those, also set A, B, and C for certain test databases. Your Trove allows you to do that, so have basically different groups targeted at different instances. We also made some headway into integrating with Heat. So traditionally, Trove made API calls directly to the OpenStack services themselves. So it would make a Nova call to provision your compute instance, pull, make sure that the compute instance is up, and then go ahead and do all of the other tasks. So, but with Heat integration, we now have default templates for each data store. And we sort of call the Heat API and say, here, this is the Heat stack. Please spin me up this Heat stack. And then we just use talk to Heat to figure out whether the Heat stack was provisioned correctly or not. And that way, we don't have to sort of talk to Nova or Cinder individually. We also support user-defined custom Heat templates per data store. So for example, if you wanted to do something else as part of your Heat stack that Trove doesn't already do, Trove will let you plug in your own custom Heat template, and it will use that to spin up the Trove instance. I spoke a bit about this before as well. We added support for incremental backup and restore. So it's no longer required that we perform a full backup every time a user needs to do a backup. And the way you do this is you'd now specify a parent backup in the API call. And this leverages extra backups ability to perform incremental backups, and you could chain multiple backups. So you could have an incremental backup that's sort of based on another incremental backup, and when doing a restore, it will sort of walk through the chain and then restore it to the point. So apply the base and apply the incrementals on top of it so that your database is in the consistent state after. We also added a new component called the Trove conductor. Historically, the Trove guest agent has had access to the Trove database directly. And Icehouse Plus, the guest no longer needs this direct connection to the Trove database, the Trove database being the service, the MySQL service database. This was a security issue since every sort of guest agent needed access to the Trove database. So now, basically, the guest agent sends an RPC message over the message bus to the Trove conductor, and the Trove conductor handles connecting to the database and updating shared state. The two sort of initial messages that we have that the Trove conductor takes care of are heartbeat messages and then backup restore checks. And they're sort of planned, an incremental plan to sort of support other messages as well. So, other smaller things that happened in Icehouse for Trove, no more XML. So we supported an XML API, but nobody ever used it. So we decided that this was just unused code in the repos lying around, and so we got rid of it. We added support for Tempest API tests. Wanted to be good OpenStack citizens, and Tempest integration test coverage numbers were low, so added support there. We also added a bunch of documentation, and we added a new Trove deployment guide, Trove developer docs, and did a bunch of cleanup work for already existing documentation that we had. So that was Icehouse. Now I want to take a few minutes to just quickly walk through what's new in Juno. And this will be the segue to Doug, who will sort of go through a demonstration of some of these newer features. So the big feature that we're sort of working together in Juno, or at least the 2 or 3 big features, the first one of which is replication, specifically asynchronous MySQL master-slave replication. The idea here is that we'd support new and existing instances. So if you already had a Trove instance, you'd be able to create another instance and set it up as a slave of that previous instance. And then Trove would take care of configuring MySQL in such a way that it would configure the previous instance as the MySQL master, and then configure excuse me, the new instance as a slave, and replication would be automatically set up. As part of that, Trove also we're working on a new API to be able to promote a slave to a master, which basically says, hey, this slave is no longer getting replicated data from the master. I want to detach it and make it its own master. So we also added Neutron support in Juno, and this is sort of done and checked in. So the basic idea here is on an instance create call, you could specify a list of network interface or networks as the NIC parameter. And then on instance create, it would go create your Nova instance with all of those NICs. Trove also supports default Neutron networks for managed networks. So as configuration, you could add in a list of Neutron networks that are sort of your management networks. And Trove, in addition to creating your instance with any customer NICs, will also add these NICs for your managed networks to the instance. So your instance now is on your managed network as well as your customer's network. There were a lot of Horizon sort of Trove dashboard enhancements to enable this support as well. So as part of instance launch or instance create now, it takes in these NIC parameters and lets you do that through the UI as well. We also made enhancements to configuration groups. Some of this is still in the works. So now we'd be able to specify configuration groups per data store and version. So the idea here is that right now we support configuration groups for MySQL. We'd also want to be able to support configuration groups for some of these other NoSQL databases that we support. So configuration groups for MongoDB, for instance, and a few other fixes or enhancements to configuration groups that allow users to add descriptions to configuration groups and sort of better schema-based validation for values, like some of the things that I was talking about, like having defined minimum, maximum values and templates for the values so that we'd be able to validate that this is a valid value for a given configuration parameter. In Juno, we're also working on making a few data store improvements. Primarily, we're sort of working on a way to associate flavors with the data stores. So having a way to say that, hey, I have Mongo, and the minimum memory requirements for this Mongo data store type that I have in Trove is really this, and X, Y, and Z flavors don't meet this bar. Therefore, I want only this set of flavors associated with this data store. And so for Trove to be able to store this mapping so that when you try to provision an instance, Trove will block you, say, hey, wait a minute, that data store is not associated with that flavor. Therefore, that's not a valid configuration. And therefore, the API wouldn't let you proceed. So we're also looking at adding some initial support for other data stores, specifically Postgres and Vertica, although this is going to sort of be an ongoing process. So we'll start some of the initial support, but I'm not sure if this will complete in the Juno timeframe. Enhancements to backups. So one of the things that we're working on is making backups available across regions. So if you have a backup in Swift that's in one region, for you to be able to pull that backup from that region and create a Trove instance in a different region based on that backup. We're also working on backup and restore functionality for some of those non-MySQL data stores that we support, like Cassandra and Couchbase. A lot more testing enhancements in Juno. More Tempest tests being added. Support for guest-level API tests that didn't exist. Some further client tests for the actual Python Trove client. And scenario tests, so tests that sort of run complete end-to-end scenarios. For example, spin up a Trove instance, take a backup of that instance, do a restore of the backup, and make sure things are working end-to-end. So we're working on that as well. We're also looking at trying to support some upgrade testing through Grenade. Again, I think this is one of those things that will start in Juno, and this will be ongoing, and we'll have to figure out through Kilo as well. So some of the miscellaneous items that we're trying to complete in Juno, support for capabilities. The idea here is basically for Horizon to have a way to query what things are turned on or turned off in your particular deployment of Trove. so that it's able to display the correct UI panels to the user based on that. So for example, if you didn't have volume support turned on in your deployment of Trove, then there's sort of no sense in showing the volume options in Horizon. So have a way for Horizon to determine that programmatically and turn it off. Migration to Oslo messaging, the Trove messaging code that exists in the code base is sort of old, so we really need to be able to migrate to Oslo messaging. A few more heat enhancements and a lot more work being done on improving logging and documentation. That said, I'm going to sort of transition to Doug, who will talk a bit more about replication in Trove.
Thanks a lot.
Thank you, Doug.
OK. So before I get started, I had a couple things I wanted to mention. So first thing, Ken mentioned that we joined the community about, I guess, 8 months ago. And it's been a very interesting 8 months. And I got to say, the community's been very welcoming. We attended the mid-cycle in Austin, Texas, Summit, and got to meet almost everybody that we work with day to day, from Rackspace, HP, eBay. And I think the welcome we got from them was tremendous, and I just wanted to state publicly I really appreciate it. So all the contributors are in the room. Thank you very much. The second thing is specifically with regard to Nikhil. He was elected PTL in April, I believe, and he's done a tremendous job. And I have to say, it's incredible how much the guy works. I really don't understand how he does that, because I wake up in the morning, say at 6 a.m., and I look on IRC, and he was on there at 4 a.m. Now, I get the fact that he's 3 hours behind me, but still. So I wanted to just mention that we really appreciate that, the whole community, Nikhil, and I hope people show that to you over the next several days of our mid-cycle. And the third thing, and this is on top of all that, I wanted to mention Nikhil got married a week and a half ago, and he's here at our event. So congratulations, Nikhil. Interesting honeymoon choice, but so I guess that's my administrative item. So on to talk about replication. So which button do I push? We'll figure that out. So one of the features that Nikhil just mentioned in Juno is replication, and it was one of the things Tesora worked on in conjunction with the community, and I just wanted to talk about it and then show you a demo of what's coming. So just kind of recap, Nikhil touched on some of this in his presentation. So the way we approach this is, there had been lots of discussions about replication in the past with the community, and we kept talking about it and realized that if we tried to basically boil the ocean, the feature would never, ever get done. So we took this kind of versioned approach. And we decided to, we're in the Juno cycle, so the first version was going to be in Juno, and basically focused in on read replicas for MySQL. So that's as a scope of that feature. The intention is that over time, we would broaden this out to more support for beyond read replicas in MySQL, and obviously for other data store types, but that's the focus in Juno. And basically, some of the other things we considered that are post-Juno would be things like master-master failover, the multi-zone DR kind of scenarios, and different kinds of replication strategies beyond asynchronous MySQL replication. But for Juno, we're focused on MySQL async read replicas. So in Juno, the capabilities, the details of the capabilities we launched. So you can now launch a slave from an existing master. And basically, the slave is bootstrapped from a snapshot of the master. And the replication strategy that's implemented in Juno is basically MySQL native asynchronous replication it's using. And the replication starts from basically the bin log position that results from the snapshot that was provided at the time you started it. The master can support many slaves. I actually don't have any idea whether there's a theoretical limit, but you can have one master, several slaves. The other thing we've implemented is the replication is monitored by Trove. So if something happens, like there ends up being a delay in the replication for some reason, that actually is shown. And also if for some reason slave gets disconnected from the master, that's also displayed. And you can also promote, detach, promote, whatever the word is. I think we're still just trying to figure out what the terminology there is, but you can basically disconnect a slave from the master, and effectively at that point it could become a master. So, demo, right. So if we could just flip to this. Oops, there we go. Okay. So before I did a demo at Summit in Atlanta, and it was a very scary thing to put together, and I got some very sage advice from a good friend of mine, Michael Bazenite, who said, don't do a live demo, are you a fool? Well, I think he was a little more colorful than that, but so he told me, videotape it, because otherwise it's gonna fall over and you're gonna look dumb. So I'll probably look dumb on my own, so I figured I wouldn't have this to do it. So this is a video. I'm gonna walk through it, stop it, talk to what I captured this. I actually ran it, so this is real running code. Second thing, you'll notice this says Tesora OpenStack Dashboard. So earlier on, Ken mentioned that we are releasing Tesora DBaaS Platform Enterprise Edition shortly, in a few weeks. This is part of it, so we've kind of packaged Horizon and Trove together. So Horizon includes the Trove dashboard, and Trove is the Juno release as it exists now, so it includes replication. So I just want to go through that, so let's just go here. So we're just going to sign into Horizon. And I'm going to take you through, hopefully you'll recognize some of the dashboard components. We're going to go into the Trove dashboard, which is under the database project. So basically, here's the instances panel. So I have no instances at this moment. So the first thing I'm going to do is I'm going to launch an instance. And with the magic of video, the instance comes up obscenely fast. So I'm going to launch a master. I'm going to pick a flavor. So I've created a specific flavor called dbaas.m1.tiny, which is basically, I think, 512 megabyte, 5 gigabyte a volume. And you'll notice I'm going to do MySQL 5.5. I'm also going to provide, and this is some of the things Nikhil talked about, features of Trove, but I'm going to provide a database and an admin user so that I can, after this launches, connect to it and do some things on there that actually prove to you that replication is actually working. So here we go. We're going to make test DB. I'm going to make a test user. And then I'm going to push the launch button here. It'll pop back to the panel and it will launch radically fast. So there it is, it's up. So now I'm going to actually, so now that it's running, I can click on the link to the instance and it'll show me some details about the instance. For most people, probably the most important detail is the actual locator info to tell you how to connect to the thing. So that's there at the bottom. So it says it's on 10.0.0.2, because I didn't use the DNS designate feature, so I don't have a host name. So now what I'm going to do is I'm just showing that, okay, so I have my users and I have my databases there. Now what I'm going to do is I'm going to connect to phpMyAdmin, because when I did the demo in Atlanta, I used the MySQL command line client and it doesn't look as nice in the demo. So that was advice from my CEO. So I'm going to use phpMyAdmin to populate the database so that when we make the slave, you can actually see that I didn't lie and it actually created a snapshot and replicated. So here we go. So this isn't software that we wrote. This is some other community. So I'm just going to pull up a schema file that I have from some previous life and load it into the database here. And the most important part here is to see this data. It's got all my friends' name in there and their credit limit. Okay, so now what I've done, so I've created a master. I connected to it with an application, effectively, phpMyAdmin. I loaded schema and data into it. And now what I want to do is I want to create a read slave, a read replica. So what I'm going to do is go back into our Trove dashboard. and I'm going to launch another instance, but this time I can launch it as a slave. So similar, I pick a name for it. I'm going to call it my slave. I pick the flavor. I'm going to use the same flavor. It's MySQL. This time I go into the Advanced tab, and now magically under this Replicate from Instance drop-down, my master shows up there. I pick that and hit Launch. So you can see what it's going to do. The master instance will actually go into backup state. So it's doing a snapshot of that instance right now. Then it's going to put the master back active and basically build out the slave by applying that snapshot and then turning on, doing all the necessary replication configuration. So now both those are active. So what we can do is go actually interrogate them with the, click on them and do the show command to see what their details are. Come on, here we go. So you'll see now at the bottom of the show information, below the connect info is this slave of replication, which provides a link back to the master. So I clicked on that link, and it takes me to the master details, and you'll see now under the master, it shows that there's a slave. And I didn't do this in this demo, but if there was more than one slave, they would all be listed down there at the bottom. So I go back to the slave, and I just wanted to show so that you can see that the users in the databases that were on the master are now present here, and I didn't create those ahead of time. They came over from the snapshot. And I'm going to run my application here, phpMyAdmin, and I'm going to go into the slave and check to see if my customer demo schema loaded there. So there's my test database. And I'm going to check this customer table, and what do you think is going to happen? Is there going to be any data in it? There you go. Okay, so that's to show that the setup of replication successfully concluded. So the snapshot came over, and we now have a slave starting on the snapshot. So the next thing I wanted to do was actually show you that replication is active. So I'm going to change some data. I'm going to connect back to the master and with phpMyAdmin. And I'm just going to go back into that customer demo table, and it really isn't correct that my credit limit is lower than all these other guys, so I'm going to make it higher. So let's just do that. I'm going to just use phpMyAdmin to edit my credit limit to 5,000, which is still too low, but anyway. And do that update on the master. And then what we're going to do is connect back over to the slave. And assuming all the stars lined up, the data should be there. All the stars line up or the video worked, either one. So there it is. Ooh. Okay, so now what I'm going to do is I'll show you the status checking. So the status, the two things that are being checked are whether replication's delayed. What I'm going to demo here is that what occurs to the status when the master goes away, or there's a network hiccup or whatever. And I'm going to simulate that by basically, I'm going to connect to the master and basically stop the MySQL service. Okay, so that's what I just did here. So I connected to the master, stop MySQL. And what you'll see in the Trove dashboard is basically the slave shows as detached. And it'll stay there spinning like that until it gets connection again. And you can see also the master is shut down. So I'm going to just go back into my master, start MySQL back up again. And the slave will reconnect its replication, and the status will get updated to active again. And then the next thing I wanted to show was the detach. So this would be where you decide for some reason that you don't want the slave to be a slave anymore. You can actually disconnect the replication and effectively promote it to being a master, if you like. So here it is, detach. Confirm, and then it'll basically. Now the status, I think this is something we're talking about in the community, like the status of active. So you can't tell on this panel whether the slave is a slave at that moment, right? So I think there's some discussion going on about whether we should change that. But if you drill into the instance through the link, you can actually see that the replication slave of information is now gone. it's no longer connected to the master. It's not a slave. And the master doesn't show it either. So that's my demo for today. I think, can you flip back to the slide deck? So basically, what we wanted to talk about was, we're a growing community, and we're looking for people to join all the time. And in fact, we joined, and it was a very positive experience. So, and there's lots of things we want to do with Trove, make it better. So obviously, everybody's input and help. And I think this goes to Mike's discussion about ecosystem. I think you can certainly see it in the community in terms of all the work going in to improve the project and the product. So.
Okay, great. Well, thank you, guys. Oh. Thanks.